Hello, Luke. Welcome to Lesson 78. Today we're going to be talking about rational equations. Pretty straightforward today. Should be a fairly easy lesson. So, what are rational equations? Well, as I've said before, this word rational, whenever we see it, we should think fraction. Okay? You see the word ratio in the word. And remember, a ratio is just a fraction. Okay? So, rational equations would simply mean equations that have fractions in them. All right, so let's take a look at this first equation. And what they're going to ask you to do is to solve this equation. And if we look at it, we note that it has a bunch of fractions in it. And whenever we have fractions, it just complicates things a bit, right? Adding, subtracting, multiplying, dividing fractions, it's never fun, and sometimes it can get pretty, tedious. So there's going to be a strategy that we're going to use here to make this a little bit easier to do and to hopefully help us make fewer mistakes when we're solving these equations. All right, so what is the method that we're going to use? The method is, maybe I'll just write it over here. The method is to first multiply all terms by the least common multiple. Of the denominators. Okay, and this is nothing new. We should know how to do this. All right, so if I have, let's just say I have, fractions that have these denominators and I was trying to add them. So if I had 1/2 plus 1/4 plus 1/6, if I had something that looked like that, what would we do? Well, we would look at our denominators and we would try to find a common denominator, right? And to do that, you would find the least common multiple of the denominators. You would take that 2 and that 4 and that 6. Whoops, excuse me. Write that a little clearer. That's 6. And you would ask yourself, what is a common multiple? Preferably the least common multiple of these three numbers. Okay? So in other words, what number can all three of these go into? And what's the smallest number that all three of these can go into? Well, the answer would be in this case for these three, 12, right? 2 can go into a 12, 4 can go into a 12, and 6 can go into a 12. And in fact, that's the smallest number, the smallest multiple that all three of these numbers can go into. So this would be our least common multiple, our LCM, if you will. And that is what we would use as our common denominator, right? Nothing new there. That's just old school, just knowing how to add fractions with uncommon denominators. Okay? The same thing is going to be applied here. Only because it's an equation, we're going to approach this a little bit differently. The goal is to get rid of the denominators, all right? To get rid of the fractions, essentially. And to do that, the first step is to find the common multiple, the lowest or the least common multiple of these denominators. And then we're going to multiply all terms by that least common multiple. Since I can multiply both sides of the equation by any number that I choose, that is totally permissible. All right. So if we have a 2, 4, 6, what's the lowest common multiple? Well, we just said a minute ago when we looked at these fractions, the lowest common multiple is a 12. So what we're going to do is we're going to multiply everything by 12. We're going to multiply this whole side by a 12. But that means that we have to multiply this whole side by a 12. Okay? And when we do this, a beautiful thing is going to happen. So if I take this 12 and distribute it through, what happens? Well, a 12 over 1, essentially, multiplied by a y over 2, means that this 2 is going to cross cancel with this 12, and it's going to become a 6, right? So that I can cross out. It's going to become a 6. And then I have 6 times y, which is going to be 6y. And of course, in the denominator, I have just 1 times 1, which is 1. And 6y over 1 is simply 6y. So notice how we lost the denominator there. Okay? We lost the fraction. Now, we need to take that 12 again. Maybe I shouldn't have crossed it out, since we're going to be reusing it here, since we have to distribute it through. So now we need to take this 12, and we need to multiply it by the next term here in the parentheses, which is the positive 1/4. And again, the 4 can cross cancel, can go into itself once, it can go into 12, not 6 times, but 3 times now. Okay? So we end up with plus a 3 times a 1, which is just a 3, over a 1, which is just a 3. Leaves us with the 3, right? Equals, on the right-hand side, if we multiply this by a 12 over 1, the 6 will cross-cancel, and we're left with a 2 times the y. It's going to give us 2y, right? So you see how our denominators were eliminated. And they were eliminated by multiplying everything by the least common multiple of all the denominators. So you see we were able to cross out the 2, 4, and 6. That was by design. That was by design. That's why we multiplied everything by a 12, because we knew that 2 could go into a 12, 4 can go into a 12, and 6 could go into a 12. So you see how finding that least common multiple is in fact setting ourselves up to eliminate these denominators, because we know these denominators will cross cancel with their least common multiple. Okay? Now once we've gotten it to this point, the rest is simply review. Now we're just simply solving this equation for the y. So we can move the 2y over to the other side, combine all of our y's here. I'm going to combine a couple steps here and move the negative 3 over to the other side as well, or the positive 3. Move it over to the other side. And these will eliminate. And a 6y and a negative 2y is a 4y. Equals, these eliminate, and we have a negative 3. So y is going to be equal to a negative 3/4. Okay? So hopefully that makes sense to you. It's actually really straightforward. It's not very complicated. All we need to do is remember the process. We need to find the least common multiple for all of the denominators in the equation, and then multiply everything, both sides, by that least common multiple, and then the magic happens. The denominators get eliminated, and we get rid of the fractions, which is great. Makes it a lot easier to solve. All right, so let's try a couple of these and see how you do. So this one's very straightforward. Why don't you pause the video? It's very similar to the last one, and try it yourself, and then we'll do it together. All right, so let's see how you did. So we have fractions in our equation. So right away, that should kind of clue us in on the fact that we want to get rid of the denominators. So we have a 7, we have a 2, and we have a 3. So what's the least common multiple of a 7, 2, and 3? Well, easiest way to do it is look at the biggest number, 7. We know that 7 can go into 7. Can the others go into 7? Well, no. 2 can't, 3 can't. So 7 is not our least common multiple. So what's 7 times 2? 7 times 2 is 14. 2 can go into 14, but 3 cannot. So that's not going to work. Let's try a 3. 7 times 3 is 21. 2 can not go into 21, so 21 isn't going to work. 7 times 4 is 28. 2 can go into 28. A 3 cannot. And so you kind of get the idea. You can kind of work your way up with the biggest number and try to find the first multiple that all 3 can go into, right? The other way to do this is to recall how to use your factoring, right? So what are the factors for a 7? Well, it's just a 7, right? Factors for a 2 are just a 2. A 3 is just a 3. So we're dealing with, all of these factors, and we would then choose, how many of each of the factors we have. We're dealing with 2s, 3s, and 7s, and the most 2s we have are just 1. The most 3s we have are just 1, And the most 7s we have are just 1s. So it's going to be a 2 times 3 times 7. So if we had continued with what I was doing originally and just taking the 7 times the 4, checking to see if the others can go into it, and then if it doesn't, try a 7 times a 5, we would have kept going until we hit 7 times a 6. All right, because that's what this is here. 7 times 3 times 2, which is 7 times a 6. So when you multiply all of that out, you get 42. All right, so 42 is the LCM in this case. All right, so feel free to use, really either method. Sometimes maybe it's a little faster to just recognize the largest number and just try to take the first couple of multiples of that and see if the other two can go into it. But if that's not working, or if you feel like, it's dragging on, go ahead and do these factors, right? Hopefully you remember how to do that. You have to take the factors of all of them, figure out what are the factors that you're dealing with, and then pull out the greatest number of those factors in any one of the numbers and multiply it all together, okay? All right, so in this case, our lowest common multiple is 42. Okay, so now we're going to multiply everything by 42. So we multiply this side by 42, and we multiply this side by 42. And if we set that as a fraction, 42 over 1, that's fine. And then we can cross cancel. So 7 can go into itself once. It can go into this 6 times. So then multiplying this through, we'd have 6 times 2x, which is going to give us 12x. And again, it's over a 1, which just means 12x. Multiplying this through to the next term, we have the 2 is going to cross cancel, and this is going to become a 21. So we'll have 21 times a 3x, which is a 63x, equals, over here the 3 can cross cancel with the 42, and the 3 can go into 42 14 times. Okay, so then we have 1 times 14 is simply 14. And now we're back to the easy part. Now it's just review. So let's combine these two terms here. 12x and a negative 63x, they're like terms. So what's that going to be? Negative 51x equals 14. And if I divide that out, I end up with x is equal to a negative 14 over 51. And that's actually reduced. We can't reduce that anymore. So that is our solution for x. All right? Great. Let's try another one. Now this one maybe we'll do together, and then the next one we'll do, I'll have you do it on your own. This is just, this is probably as complicated as it's going to get. Again, here we're dealing with some fractions, and they don't all have to be fractions, by the way. I think the other two problems, every term was a fraction. But notice this one, they're not. We have two terms that are fractions. This one over here is not a fraction. That's totally fine. We can still use the same method to eliminate these fractions and make the problem easier to solve. All right. So here, just remember that this denominator is a 1. All right, so what's the lowest common multiple between a 2, a 7, and a 1? Well, the 1 we don't really care about because that's a multiple with everything. So really looking at the 2 and the 7. And the lowest common multiple, the LCM, is going to be 14, right? So if we use 14, we will multiply both sides by 14. Now, there's one little thing here that I want you to observe when we do this. And that is remembering that we're multiplying this 14 by everything. And so this first one here, this first term, is probably going to be pretty straightforward. The 2 is going to cross out. This is going to become a 7. And we're going to have 7 times 3y, which is 21y. But this next one, let's look at this one a little closer here. So if I take the 14 and I multiply it through this term, keep in mind what's happening. It's true that the 7 is going to cross cancel, and the 14 would become a 2 then. And then this 2 is being multiplied by the numerator, okay? It's being multiplied by the numerator. And the numerator here is a binomial, okay? So we have to be careful because we don't just multiply this 2 by the 8 and write it as 16 minus 4y. That would be incorrect. This 2 is being multiplied by all of this numerator. So it's actually easiest when we see these binomials to go ahead and just put them in a set of parentheses, just to remind ourselves that that is the full numerator. And then when we multiply that numerator by a 2, it's easier for us to recall or to remember that this 2 has to be then, maybe I'll change color, this 2 has to be distributed through this numerator. Okay, has to be multiplied by both of those terms in the binomial. Okay, so whenever you see this binomial in the numerator, just put it in parentheses, just so you make sure that you're treating that as one entity, and that'll remind you to distribute that 2 through when you multiply. All right, so when we multiply this out, we have 2 times 8, which is going to be the 16, and then 2 times a negative 4y is a negative 8y. And then on the other side, it's obviously pretty easy. It's just 3 times 14, which is what, 42? I believe, yeah, 42. All right, then we will progress here to the regular equation. Combine our like terms. We have a 21y and a negative 8y. That's going to give us a 13y plus 16 equals 42. We can subtract the 16 from both sides. 16s will cross out. We're left with 13y. And if we subtract these, what do we get? We get 26. Yeah, 26. And then finally, we can divide out the 13. And we're left with y is equal to 2. Look how nice that worked out. Y is equal to 2. Okay? Very good. Let's try one more. And by the way, I've been taking all of these problems directly from your book. So if at any point you don't recall some of these, you can look back in your textbook because these are the same sample problems. Okay? All right. So let's try this one. Why don't you go ahead and pause the video, do this one on your own, and then we'll do it together. All right, so the first step that I'm going to do here is maybe just recognize, okay, we're dealing with fractions in an equation. The first step is going to be to eliminate those fractions. Makes it easier for us to solve it. But after that, we need to recognize that we got some binomials here in the numerator. So I'm just going to, like I said earlier, put these binomials in a set of parentheses, just so that I don't lose track of those entities and I treat them as one single entity. All right. Now I can find my LCM, my least common multiple, between a 2 and a 4 and a 10. So that's a good one. 2, 4, and 10. What's the least common multiple? Well, looking at it, I'm going to say it's 20. Okay? The least common multiple, 20. I think that's the smallest thing that all three numbers can go into. All right? All right, so let's multiply both sides by a 20. 20 on this side. I'm just going to write it as a 20 over 1, just to remind us that we're using it as a fraction. And the 4 is going to cross out with this 20, and we're going to get a 5. So we need to multiply the numerator by the 5. Now notice that's where my golden parentheses come in here. This 5 is being multiplied by this numerator, which means we need to distribute it through, right? So we end up with 5x plus 5. Okay? Then we have our minus sign right here. This 2 is going to cross out. We're going to get a 10. So we'll have a 10 times a 3, which is 30. There we go. That's our left-hand side. Now let's look at the right hand. This 10 will cross cancel with the 20, giving us a 2. This 2 then has to be multiplied again through this golden set of parentheses in here. So 2 times a positive 2x is going to be 4x. 2 times a negative 9 is going to be a negative 18. Now we're back to just normal equation solving. So we will subtract the 4x from both sides here. And we can also combine some like terms here. We've got a plus 5 and a negative 30. So we're kind of doing a couple steps here at once. Here we'll have a 5x and a negative 4x is going to give me just an x. Positive 5 and negative 30 is a negative 25. Equals. These would eliminate, and we're left with negative 18. Now we can add the 25 to both sides. And we're left with simply an x on the left and a 7 on the right. 25 minus 18 is 7. So x is equal to 7. All right? So hopefully that made sense. Again, it's pretty straightforward. The hardest part might be actually just finding our lowest common multiple. So hopefully you haven't forgotten how to find that least common multiple. We did do a lesson on it way back when, and we've been kind of using that method for a while now for adding fractions and whatnot. So hopefully that'll be pretty straightforward to you. The rest is just, canceling out the fractions and then solving the equation as usual. All right, well, we will stop here, and I will see you tomorrow.